Hello class, welcome to another video for this chapter. In this video, we're going to section 3, 6.3, inverse trig functions. So far we learned about trig functions such as sine, cosine, tangent, cotangent, and secant and cosecant. Recall inverse function, and let's discuss the inverse function for this trig function. If a function is one-to-one, then simply if you just switch the input-output values, that new function is called the inverse function. But perhaps you notice that none of these trig functions are one-to-one. So none of them has inverse unless we restrict the domain. So to define inverse trig function, we have to restrict the domain. And this is the way we restrict the domain. We restrict the domain in a way that it contains the angle 0. So for example, for sine function, we limit the domain to negative pi over 2 to pi. I'm gonna draw them one by one. So for sine, so let me first show you the graph of sine. So you know that this is the graph of sine, right? And it's not one-to-one. Look, it fails the horizontal line test. So that means that if you just want to use the entire domain, then sine does not have inverse. So we have to restrict the domain in a way that it is one-to-one. So for example, what we are going to do is we are going to limit the domain between negative pi over 2 and pi. So in this way, this pi over 2, negative pi over 2. And you know that at pi over 2 is 1. At negative pi over 2 is negative 1. So we restrict the domain. So for sine of theta, we restrict the domain to negative pi over 2 and pi over 2. It contains the angle 0 and it also is one-to-one. So it's possible to define the inverse. So we define the inverse function. We are going to look at the inverse function, sine inverse. Let's first look at it graphically, because you know that when two functions are, recall the inverse function. If two functions are inverse, then they are the symmetric respect to this line, y equal x. Recall that? This is the line of y equal x. If two graphs are inverse of each other, then using this line, we should be able to draw that graph. It's going to be just a mirror image. The inverse function, the inverse graph, is going to be just the mirror image of the original graph respect to this line. So I'm going to use this line. I'm going to treat this line as mirror and then draw the graph of inverse. Okay? So in this picture, the blue graph is the graph of sine. The red graph is the graph of sine inverse, because we know that graphically, inverse of a function is just the mirror image of the original function respect to this line of y equal x. Okay, so this is the inverse function. And if you want to know what is the, let's discuss it. What is the domain of sine inverse? So we defined it to be domain of sine inverse is gonna be, so look at the sine. So we restrict the domain for sine to be pi over 2 and pi over 2, and we know that the range is from -1 to 1. Recall that when it's inverse, you just switch the place for range and domain. So domain is going to be range of this one, -1 to 1, and range of inverse function is going to be the domain of the original function. Okay. So that's the so that's about sine. So for sine, we define the sine inverse. Sine is 1 to 1 over negative pi over 2 to pi over 2. And then it's just, so over this interval, just switch the input output value that gives you the inverse function. And the domain is negative 1 to 1 and the range is this. Similarly, you can discuss, you can derive cosine. So for cosine also, limit the cosine to the interval, I think they limit it to 0 and pi, yes. 0 and pi. So look at the graph of cosine between 0 and pi. Okay, graph of cosine between 0 and pi is like this. So this is cosine of theta. And then it's 1 to 1 and it contains 0. Now, the line and then so it's gonna be so look, what is the domain of cosine? Domain of cosine, it's 0 to pi. What is the range of cosine? It's negative 1 to 1. Negative 1 to 1. Now, if we can define cosine inverse, the inverse function. So the domain of cosine inverse is gonna be, the domain of cosine inverse is gonna be, if you just switch the domain and range, is gonna be negative 1 to 1, and range of the inverse is gonna be 0 and pi. Okay, so just switch the domain and range for these two functions. So maybe I should draw the cosine inverse in a separate picture. So domain is negative 1 to 1, range is 0 to pi, and the graph is gonna be like this. How do I know it's like this? Because, I mean, I know that it should be something like this, right? But at a different place of this coordinate system, because we are switching the x and y. So that's the graph of cosine inverse of theta. And this is the graph of cosine of theta. Okay? So this is the graph of cosine inverse, and the domain is negative 1 and 1, the range is 0 and pi. Finally, for tangent, limited to 1 of the period, because tangent is also not 1 to 1. So for tangent of theta, for tangent function, limited to negative pi over 2 to pi over 2, right? So this is tangent. It has a vertical asymptote, right, at these two, and the graph is like this, right? This is the graph of tangent. Now, for the inverse, this is 1 to 1, so we can define the inverse. Let's first talk about domain and range. What is the domain of tangent? So here we defined it from negative pi over 2 to pi over 2. What is the range? range is from negative infinity to positive infinity, everything. Now, for the inverse, just to find the domain and range of the inverse function, tangent inverse, just switch the domain and range of the original function. So this is going to be everything. So it accepts everything, but it gives us value between negative pi over 2 and pi over 2. So your graph, so the graph of inverse function, it doesn't, the range doesn't go beyond negative positive pi over 2 and negative pi over 2, right? It accepts everything. It accepts everything except it accepts everything, and range is a value between negative pi over 2 and pi over 2. And I kind of know that the graph should be something like this. The shape of the graph should be something like this, right? So it's going to be like this. So this is the graph of tangent inverse function. The inverse of tangent function. So it has two horizontal asymptotes. And so the domain is everything, ranges between negative pi over 2 and pi over 2. By the way, this is the graph of tangent, and this is the graph of tangent inverse. By the way, for inverse function, we can also call the sine inverse as arc sine function. We also call cosine inverse as arc cosine, and tangent inverse as arc tangent function. They are just different name and different notations for the inverse function of this trig function. Okay. So, and here you have the graph of sine inverse, cosine inverse, and tangent inverse. Now let's look at example 1. Okay, so it's just about evaluating sine inverse, cosine inverse, and tangent inverse for some given value, evaluating the function. Okay, it's like a warm-up question. Okay, so example 1 is evaluate sine inverse of half. Sine inverse of half. What is sine inverse of half? So in other words, the question is, because this is, because this is sine inverse, so that means there is a theta, there is an angle, there is an angle theta, there is an angle theta such that sine of that angle is half. So the question is, what is theta? What is the angle that gives us half? What is the angle? The sine of that angle is half. So we know that there are many angles in general that gives us half. But because this function sine inverse is defined over negative pi over 2 and pi over 2. So the question becomes between negative pi over 2 and pi over 2. So like here, this is negative pi over 2, this is pi over 2. So over here, which angles give us a half, sine of half? And that angle is pi over, sine is half, so pi over 6. So because over this range, there is only one angle that gives us the height of 1, and that's pi over 6. So the answer is pi over 6. So in other words, what angle theta would satisfy gives us sine of theta half. And there are multiple angles like pi over 6, 5 pi over 6, and so on. But because the domain is restricted to this range, over this range, it's only pi over 6. Now let's evaluate sine inverse of negative square root of 2 over 2. Sine inverse of negative square root of over 2. So the question is, for what theta for what theta, we have sine of theta is negative square root of over 2. So there are many thetas, but because sine inverse is defined for what theta in the range of negative pi over 2 and pi over 2, we have this identity. Okay, so again, let me see. We are looking at negative pi over 2 to pi over 2. So we are looking over this range, right? And I know square root of 2 over 2 comes back to pi over 4, but pi over 4 gives me positive value. So it was negative 1. So it should have been, then this is pi over 4. So it should have been negative pi over 4. Okay, so negative pi over 4 gives me this one. Cosine inverse of negative square root of 3 over 2. So now let's do this one. Cosine inverse of square root, I think negative. Right? So again, here the question is for what angle in, what was the domain of cosine inverse? It's between 0 and pi. So what is the angle between 0 and pi such that cosine of that angle is negative square root of 3 over 2? That's the question. So domain of this cosine inverse is between 0 to pi, right? What angles give me negative square root of 3 over 2? Because it's negative, so definitely it's in the second quadrant. Square root of 3 over 2 is related to, what is the fundamental angle? It's pi over 3. Sorry. Cosine is this, so it's pi over 6. So we know that for pi over 6, the cosine is positive square root of 3 over 2. But this is negative square root of 3 over 2, so it's this angle. Okay? Pi over 6. So what is this one? This angle is pi minus pi over 6. So it's going to be 5 pi over 6. So the answer is 5 pi over 6. Okay. So the answer is 5 pi over 6, right? The last one is tangent inverse of 1. Okay, tangent inverse of 1. Okay, so the question is for what angle theta in, what is the domain of tangent inverse? The domain of tangent inverse was negative pi over 2, in negative pi over 2 and positive pi over 2. We have tangent of that angle is 1. That's the question. Okay, so tangent is 1. I know it's related to pi over 4 because pi over 4 is the value that has same sine and cosine. So it's whatever it is, it's related to pi over 4, 45 degree. But we are looking at the domain is between negative pi over 2 and pi over 2. So in the unit circle, we are just looking at the angles over this region. Oops. So we are restricted to the angles over this region, right? And I know that, yes, pi over 4. The answer is pi over 4. Because at pi over 4 is the only angle that tangent of pi over 4 is 1, and it's between these two. It's in the domain. Okay. And sometimes you may have values that, you need to use your calculator, because, these values in this question, like half, 1, square root of 2 over 2, square root of 3 over 2, these are values that we know their angle, but for many values, we don't know what is the angle, and we have to use a calculator. For example, like here, sine inverse is 0.97. So I have to use a scientific calculator. For example, let's go to GeoGebra and use this free scientific calculator. The question is, what is the sine inverse? So let me go to keyboard, go to function sine inverse of 0.97. Okay, just be careful. The answer that you get is an angle. Now, the measurement could be degree or could be in radians. And that depends on the setting of your calculator. Now this one, 75.93 and so on, is in degree, right? So if the question is, what is the angle in degree, then you say in degree mode, sine inverse of 0.97 is almost 75.93. But if you need to give your answer in radian, then you have to go to the setting of your calculator and change the setting from degree to radians, and then a value, and then that gives you the sine inverse or arc sine of this value into radians, you see. And if you round it, it's going to be almost 1.33. You see, yeah, right, you have it right here. So be careful when you use your calculator. It could be in radian mode, it could be in degree mode. If the question asks you a specific measurement, make sure you go to the setting and change it to the appropriate measurement. Okay, now let's have a couple of practices. Example 3, solve the triangle for angle theta. Okay. Example 3. What is the triangle here? So this is a right triangle. This is called theta. And we have the value of the sides, 9 and 12. The question is find theta. Okay, let's see how, you see this is a nice geometry question. But now we can use trick, our knowledge in trick, in order to solve this question. So in terms of trig function, this is the adjacent side to angle theta, and this is the hypotenuse. So which one of trig function relate, because we have the value of adjacent and hypotenuse, which one of the trig function is based on these two? Cosine, because cosine of theta is defined as the ratio of adjacent to hypotenuse. So it's gonna be 9 over 12. Okay, so the question is, what is the theta, right? Find theta. We have the cosine of theta. So one way is I don't know if your textbook wants us to use inverse, because obviously we can use the inverse function. Let me see. Yeah. Just simply, the question is, what is the theta? What is the theta? So theta is the cosine inverse of 9 over 12. You can use your calculator. Theta is the cosine inverse of 9 over 12. That's it. Now, do you want it in degree or in both of them? Okay, in degree is 41.41, and you can also find it in. So you see, that's one way to find the. I mean, once you have the output for cosine function and you're looking for the input, just use the inverse function. Now let's look at example 4. Evaluate this sine inverse of cosine of this angle. So it's a composition of two function. Composition of two trig function. This is example 4. So it's sine inverse of cosine of 13 pi over 6. Okay. So first of all, observe that this is a composition of two trig functions, sine inverse and cosine. The angle is 13 pi over 6. So what is the cosine? Let's first evaluate the inside. 13 pi over 6. Okay, 13 pi over 6. Where is 13 pi over 6? This is pi over 6. This is pi over 6, right? So 13 pi over 6 is going to be the same location because look, 13 pi over 6 is 12 pi over 6 plus pi over 6. This is going to be 2 pi plus pi over 6, right? So it's like when you go one full rotation, you go one more pi over 6. So this is going to be the same as, in terms of sine cosine, it's going to be the same. So in the first rotation, this point is pi over 6. In the second rotation, this point is 13 pi over 6, okay? But in terms of cosine and sine, it's the same thing. So cosine of 13 pi over 6 is the same as cosine of pi over 6, which is square root of 3 over 2. So then the question becomes, so now look, the question becomes, reduces to sine inverse of square root of 3 over 2. So now the question is that, what is the angle? What's the theta? What's the theta such that sine of theta is square root of 3 over 2, right? Which is pi over 3. Theta is pi over 3. Okay, got it? So first we evaluate cosine, we get a square root of 3 over 2. Then we evaluate sine inverse of that value. Example 5, find the exact value for this one. Now we have a composition, or again composition, but sine and cosine inverse. Okay. Example 5, evaluate sine of cosine inverse of what? For 4 over 5. Okay, so we start from the inside. Cosine inverse of 4 over 5. So there is a theta. There is an angle that gives us, there is an angle that is the cosine inverse of 4 over 5. So in other words, for that angle, cosine of that angle is 4 over 5. And the question is, suppose this is theta, some angle. The question is, what is sine of theta? Right? The question is, there is a theta that the cosine of that theta is 4 over 5. Now, what is the sine of theta? Look, you can easily find that because we know there is an identity between sine and cosine. We know that sine square plus cosine square is 1. So we don't know what is sine, but we know the value for cosine, which is 4 over 5. So from here, we can solve it for sine. So sine square is going to be sine square is gonna be 16 over 25. So it's gonna be 1 minus 16 over 25. This is gonna be 25 minus 16 is 9 over 25. So when you take the square root, sine of theta, it's gonna be positive, negative square root of 9 over 25. So positive or negative 3 over 5. But which one should I take? Positive or negative one? Let's see. Should I go with the positive or negative? Okay, let's see. So the cosine inverse, we know that the cosine inverse is defined from 0 to pi. So that angle is somewhere between 0 and pi, right? So I know that theta is between 0 and pi. Now, so sine is positive. So I cannot accept the negative one. So the answer is the positive 3 over 5. Why? Because sine is positive for any value. The height is positive for any value between 0 and pi. And domain of cosine inverse is 0 and pi. Okay? So the answer is 3 over pi. Let's look at one more question. These are good examples. This is example 6. The question is, find an exact value for sine tangent inverse of sine of tangent inverse of 7 over 4. So first of all, tangent inverse is defined over negative. The domain, first look at this one. Domain of tangent inverse is negative pi over 2. Sorry, it's open interval. Negative pi over 2 to pi over 2. Right? So it's somewhere here between negative pi over 2 to positive pi over 2. So the angle is right here, okay? So there is an angle in between that gives us tangent of that angle is 7 over 4. And we are looking, so there is a theta such that tangent inverse is tangent inverse of 7 over 4, or in other words, tangent of theta is 7 over 4. And we are looking for sine. Okay. So one way to do this is by looking at the right triangle. Look, because we know that in the right triangle, if this is theta, then this is adjacent, this is the opposite, and this is the hypotenuse, right? And tangent is defined as opposite over adjacent, right? So we can say, because tangent has the ratio of 7 over 4, so the opposite 7, and it's opposite over adjacent. So we can say this is 7 and this is 4, right? And then from here, we can find the hypotenuse. So hypotenuse is gonna be 7 square plus 4 square. 16, which is gonna be, this is gonna be 65. So hypotenuse is square. So hypotenuse is gonna be square root of 65. Okay, it's gonna be a square root of 65. Okay, so from here we can find sine, because now the question is that what is sine of theta, right? So sine is defined as, sine of theta is defined as opposite side divided by hypotenuse. So it's gonna be opposite, which is 7 divided by a square root of 65. Okay, so that's the big picture of this question. There are more questions. I recommend you to go over these examples, but in general, you just need to know we defined the inverse of sine, cosine, and tangent. You saw that we restricted domain to be able to define them. You saw examples on how to evaluate this using inverse function, using unit circle, and also calculator. And we also saw simplifying numerical expression and algebraic expression. So now you should be good to do the exercises of this section. That's it. Thank you for watching this video.